Done with the formula? I request you to give the formula for under individual observation only we are discussing here. Under individual observation, we are about to start with measures of dispersion. We are about to start with measures of dispersion. Under individual observation, we have four measures, right? One is range, and another one, yes, please, quartile, deviation, and another one, mean deviation, and fourth one, standard deviation. Standard deviation. So we have this four measure. Okay, we have these four measures. I request you to note down the formula from the material. So what are the formulas we have? Yes, please join with me here in the board. Range, only for individual observation I'm asking you to do. L minus S. Quartile deviation, Q3 minus Q1 divided by 2. The other name is semi-interquartile range. I'll discuss everything in detail. I just request you to make a note alone, okay? Mean deviation, 1 by n summation modulus of x minus a. Standard deviation, root of summation x minus x bar the whole square divided by n, okay? And also, you'll find something called as relative measure. This is an absolute measure and this is a relative measure. For range, we will have, you need not write this formula, I'll discuss that later. For range, we'll have coefficient of range, which is calculated using this formula. For quartile deviation, we have coefficient of quartile deviation. With the help of this formula, we do it. For mean deviation, we have coefficient of mean deviation. For standard deviation, we have coefficient of variation. Okay, not standard deviation, coefficient of variation. Okay. Before writing and explaining the definition and other things and all, first let us go for an intro. What do you mean by dispersion? Okay. What do you mean by dispersion? Please join here. Please join here. What do you mean by dispersion? All the values are scattered, which means I have hundreds and hundreds of observation. Okay. I want to have or I want to know one representative. Probably that representative would be called as what? Mean, median, or mode. That representative would be called as the average A. Okay. There is another name for average. Could you please remember what is the other name for average? Yes, you very well know. What's that other name for average? Mean, median, mode are the measures of average. Okay, what are the other name for average? Central tendency. There may be so many values, hundreds and thousands of values, but where they are marking to, all the values are tending to a central point. That's why we have this name called as central tendency. And this average can be mean or median or mode. This we have discussed in the earlier sessions. Under mean, we have arithmetic mean, harmonic mean, geometric mean, and under median also, it's a positional average. We have percentiles, quartiles, deciles, octiles. Okay, so what happens here is let me take two cases, two set of data. Set one, where I have the values 2, 3, and 4. Okay, can you help me out with the mean value? What's the mean value? 3. See, the values are evenly scattered means the center value will be the mean value. We need not go for finding the value. Let me take another set of data, set 2, which has 1, 3 and 5. What's the x bar? Again, see there is deviation of 2 and minus 2. Again, the value will be the middle value. See, it's evenly spread out means the value will be the middle value. That will be the median, that will be the mode. Okay. So here the value is 3. Now tell me whether set 1 is better or set 2 is better. If I'm given thousands and thousands of values, hundreds and hundreds of values, lakhs and lakhs of values, sometimes I cannot count and say how many values I have. Okay. So in that case, what I'm doing is I want to have one representative, and that representative means to be the mean value, median value, or mode value. That's the average. Okay. But what happens now here is in both the cases, the example which I have taken now, in both the cases, what is my mean value? Same. Then how can you say which is the best data? Either this is the best data or this is the best data. So what happens now here is even the measures of average or certain tendency plays a very important role in statistics. What we are doing here is at one point of time there may be a case excuse me, there may be a case where I cannot directly compare. Okay. So what I do here is I go for taking the dispersion values. Dispersion, or to easily get into the wordings, we take it as deviation values. See, dispersion is somewhat alien to us. So what I'm doing is I'll take the value called as deviation values. Deviation. Okay, so all the values I have like this scattered, and I have the mean value here. What's the mean value? This was set 1 data I'm drawing. What's the mean value? 3. What are the other values? 2, 3 and 4. So 2, 3 and 4. So how far it is deviated? -1, 0 and +1. Am I right? This is the deviations above. Let me go for second set 2, and I'll draw all the values. Okay, which means I'll mark all the values. And what is the representative here? Yes, please. What's the representative here? Here also 3. See, so for second data also average 3, right? So, and how the values are dispersed? Yes, please, John, is very important over here. Where are the values here? 4, 3 and this 4. What value is this? 1 now. 1, 3 and 5. So 1, 3, 5. So here, here, here. How far is dispersed? Scatterly dispersed. Okay, what do you mean by scatterly? Means thalli irukku. That's what we say. Scatterly. Here, it's very closely dispersed. Here it is scatterly dispersed. So which one I would say better? Set 1 is better. So when it happens that both the averages are taking the same representative, same value, we cannot directly compare. So we have to go for the next measure. That next measure is what you call as a dispersion. Okay. So dispersion, I can define in two angles. One is absolute values and one is relative value. Okay. Please try to understand what do you mean by absolute value and what is mean by relative value. Absolute means the exact value. Okay. Relative means compared value. For example, you have secured 90 marks in your exam. That is good or bad? 90 marks, good or bad? வீட்டுக்கு போனா திட்டுறாங்க 90 for 100, 90 for 200. That is right. 90 for 100 or 90 for 200? If it is 90 for 100, what do you say? Good or bad? Okay. 90 for 200? Absolute means 90. Relative means you have to compare for what it is 90. Okay. You have to compare for what it is 90. For what it is 90? 90 for 100. Yes, you may say it's good. 90 for 200. You may say, just pass I don't it's bad. So tell me which is a good comparison. Absolute measure is a good comparison or relative measure is a good comparison? Relative measure is a good comparison. But to have the relative measure, we need to know two values. One value is the numerator, the absolute value, and the denominator, which is the given or taken value. Okay. So here for finding the dispersion, we'll go for absolute value, then relative value. We have 4 types of dispersion. That's what I'm going to discuss in the next page. What are the 4 types of dispersion? I'm talking about absolute value first. Then I'll go for relative value. What are the 4 types of dispersions we have? Deviations. One is range, Next is quartile deviation. Third is mean deviation. And fourth is standard deviation. Okay. If you want to make a note of any range, generally range is called as the spread over of value. Spread over of values. You need not make a note of it. Just listen to the session. I'll give you time. Okay. This session is a very important session. That's why I'll go in a relaxed session, a relaxed manner only. Range, in a colloquial manner, you can say this is how the values are spread over. So if I take a mapping of all the values, okay, which means usually when we go for arranging, we'll go for ascending order. Arrangement is not necessary. Only for median, positional average, we need to arrange. And usually when we want to consider the values, if we know the arrangement, we can easily discuss. Okay. So what I'm going to do here is I'm taking the set of values arranged, usually in ascending order. Okay. There may be a least value over here. Ascending order means what? Starting from the least, going to the highest. So there will be a least value here. There will be a highest value over here. And what do you mean by range here? Spread of the values, which means the highest value minus the least value will give you the range. Okay. You'll have this as a formula. See, H for highest, L for lowest. Or you can have the formula as largest minus smallest. Okay. Don't think or don't wonder why I'm getting minus L here and plus L here. See, here H is highest, L is lowest, or how can I write it? Largest minus smallest. Okay. So this is what you call as range. Shall I go for quartile deviation? Quartile deviation. What do you mean by quartile? We have already done. It's about the positional measures. So let me again take the spread over of the values. What happens if I take ranges? If you keenly note, say I'm not considering all these values. Did you make a note of it? When I say range, only two values are considered, the largest and the smallest. Okay, so this is the, sorry, I wrote it another way, right? Smallest. Okay, smallest. Okay, or lowest. Okay. So I can write it as highest minus lowest or largest minus smallest. Okay. Only these two values, the very first value, the very least value, and the very highest value, only these two are considered. What about these values in the middle? I'm not considering anything. Which means, is this going to give me a clear picture? No. This will not give me a clear picture because we have secured 1 mark in mathematics. Yeah, ma'am, unga paper da edukanuma. Paravalla, I take the credit. Okay. We have got only 1 mark in mathematics. Zero edukalala, other happy. We have secured 100 in accounts. Happy? What is the spread over of marks? 100 minus 1, which means 99 marks you are lagging. What about other papers? Law, economics, other papers and all. Everything above 95. But still, one paper you have secured very less marks. 95, 97, 98, almost topper only. But only in math or stats. What happens? Your spread over shows us 99. Okay. Probably instead of taking maths, if you take Tamil or any other language or any other English or something, will not consider it all. Probably history, social science. Up to 10th standard is fine. After 10th, you're not going to consider that mark. So you'll be worried. எப்படி இருந்தாலும் 11th படிக்க போறது இல்ல. அது எதுக்கு ஒரு மார்க்லாம் போட்டு அதை விட்டுலாம் தோணுமா? You feel like we leave it off because it's not given much importance. What happens is when you take the highest and the largest, that is the smallest value, all other in between values are not given importance. Actually, that's a limitation for deviations. Not only for measures of dispersion, even for measures of averages, that's a limitation. To rule out this limitation, we are going for quartile deviation. The highlight of quartile deviation is simple. What's the drawback in range? We left out all the values. Now what happens is, in quartile deviation, let us take Q1. Let us take Q3. Q3 minus Q1, which means what? We focus on the middle values. Just tell me, in your class, school, either 10th or 11th or 12th standard, any standard, how many secured below 40? How many secured above 90? How many secured between 40 to 90? Or between 60 to 80? There will be many students lying between 60 to 80. Am I right? The average there will be many students lying between 60 to 80. Below 40, it's very less. Above 90, it's only a handful. So what happens here is we are focusing on the middle. which means here we are not considering all the values, but we are focusing on the middle, which means what? Middle will be having high density value. High means what? Many repetitions. High frequency will be there only. So what happens? We are going to consider quartile deviation. But directly considering quartile deviation, we'll go something or some other measure called as interquartile range. Okay, we'll call it as interquartile range. What is interquartile range? The difference between the quarters. What is the range? The difference between the highest and the smallest value. What is the interquartile range? The value between the highest quartile and least quartile. What's the highest quartile? Q3. What is the lowest quartile? Q1. Q3 minus Q1. But quartile deviation, we are not considering the first quarter and last quarter. We are considering only the middle half. So we cannot directly take Q3 minus Q1. Instead, what we are going to do is we are going to take Q3 minus Q1 divided by 2. So that's the formula. Q3 minus Q1 divided by 2. That's why it's also called as semi-interquartile range. It's also called as semi-interquartile range. So sometimes in your question paper, you will be given interquartile range value. You will be asked to find quartile deviation. What do you do? Interquartile range is given, which means what? Q3 minus Q1 is given. You will be asked to find the quartile deviation. What you do? You divide by, that's it. Okay. So it's called as Q3 minus Q1 divided by 2. This is quartile deviation. Again, there is a limitation in quartile deviation. What's the limitation? We are leaving the first quarter. We are leaving the last quarter. We are considering only the middle. Actually, that's a deviation. That's a limitation. Okay, so that's why we go for the next measure called as mean deviation. The importance of mean deviation is to consider each and every value. See, all the values are scattered. Okay. What about median? What about median? I'll take only the middlemost value. Okay. So this is the middlemost value. I name it as median. Okay. What about mode? What about mode? It can be last value, it can be any center value, but which value I'll take? The highest repeated value. But what our the syllabus discusses here is most of the cases it will be nothing but a central tendency only. It will be tending to the central value only. Okay. So this is about mode. What about the other case? Mean. All the values are scattered, but still we can find mean and we can say that's the better average. Usually means we'll talk about what? I'll write it as mean itself. Okay. We'll call it this as a best average because we're considering all the values. What's the formula for mean? We have three formulas. What is the formula for mean? Summation x by n. Okay. If you make a note of the formula, this formula involves all the values. You agree with me? Even x is 0, it involves. What happens in the case of geometric mean? X happens to be a 0 value. We cannot find geometric mean. We leave it off. What happens to a negative value? We cannot find. We leave it off. The same thing happens with harmonic mean also. Okay. What happens in the case of median? We are considering only the middlemost value. So leave that also. Mode. The highest repeated. So leave that also. So better its mean deviation is dealt with x bar, which is equal to summation x by n. So here I'm going to find x bar. You remember what property we were discussing? Summation of modulus x minus the sum value will be always minimum. Can you tell me which property is this? You can please refer Singer material. We have discussed property for mean, median and mode. Summation of modulus x minus this value, okay, is minimum always. This is for mean, median or mode. Is where it is, which property is that? Mean. Kindly confirm whether it's mean. I think you are in page number 2.7, right? What is the first one? The algebraic sum of deviation of a set of observation from the arithmetic mean is 0. Okay, leave off that. I'm not discussing that. What's the second one? The sum of square of the deviation. I'm not taking the square. I'm not taking the square. I'm taking the modulus value. So which is better? Taking mean is better or go for the median property? See, please join. What this property says, B, remember, summation of x minus x bar, the whole square will be minimum. So this is about square of the deviations and the deviation is taken from mean. I'm asking summation modulus of x minus what will be minimum? Modulus of the deviation. Go for median. What's the median's property? The second property. I'm in page number 10. Yes, please join. The sum of absolute deviation is minimum when the deviations are taken from the median. Okay. Comparing, you can find that the formula is better for summation. That is what? X bar value. But what the law says, property says is when the deviations are taken from median, it is minimum. But when we use the term mean, we are going to apply which mean? Arithmetic mean only. So there are there are three formulas. One formula is we take the deviation from mean. So summation of modulus x minus. This can be mean, this can be median, this can be mode. That's why A can take any value. It can take mean value or median value or it can take mode value. Any value it can take. So generally we'll have it as A. Why we name this as mean deviation is because what is mean formula? You add all the value, divide by n. Why we divide by n? That will be a better representative. So that's why here also we add all the deviation values and divide by what? N. So I can have this formula like this probably 1 by n summation modulus of x minus e. What is the A value? You can take mean or you can take median or you can take mode. Which is better? Median is better. But if nothing is mentioned in the question paper, you have to take for mean only. Please make a note of it. It will be defined. Find mean deviation about median. Then you can find A as median and use it. Find mean deviation about mode. You can use A for mode and use it. Okay. If nothing is mentioned, find mean deviation, which means what? We have to use arithmetic mean only, not geometric mean or harmonic mean. We have to use arithmetic mean only. You have to be very keen on this. Okay. So that's about mean deviation. But again, comparing all the averages, which is a better average? Not median, not mode. Which is a better average? Mean is a better average. Now go for the properties of mean. Yes, please turn over. Go for the properties of mean. Just now I was discussing this one. One property of mean says, what does it say? Just now we were discussing. You remember the second property? This page 2.7, I remember, right? You have 2.7. What's the second property says? The sum of the square of the deviation taken from the mean is always minimum. Which means what? Sum of the square of the deviations taken from the mean is minimum. Square of the deviations will be minimum. I have to sum it. What happens is, again, when you go for deviation, you're considering the average measure, so you have to divide by n. Okay. But whenever I go for squaring the value, actually I'm doubling, right? Doubling in the sense that I'm multiplying with the same value. If I get minus 2 as the deviation, what I'm doing? Minus 2 into minus 2, 4. Okay, if I take minus 3 as the deviation, what I'm taking? Minus 3 into minus 3, 9. I'm actually squaring their values, which means the deviation seems to be more higher. But actual picture is not that. So what I do is, because of removing the square, I do the square root. This is the formula for standard deviation. So standard deviation was a formula usually represented with the symbol sigma. Okay, only for this one we have the symbol. For others, probably for range we'll use R only. For quartile deviation, we use semi-interquartile range or QD. For mean deviation, we use mean D. That's it, MD. For quartile standard deviation, we have this sigma as a notation where it is taken as square root of summation x minus x bar the whole square divided by n. If we square this deviation, what do you get? We call this as variance. We write this as summation x minus x bar the whole squared by n. Okay. Let me go for the definition. It's quite important definition. You know the definition, right? How do you write the definition? Like in statement, you have to go in reverse order. From where you're taking the deviation? From x bar. What you're doing with the deviation? You're squaring. Then what you're taking? You're dividing by n, which means you're taking average. Summing and dividing by n means taking average. And after that, you're taking square root. If you take square root, you're aware of this concept. If I want to take square root of 4, what will be the value? Two values will get plus 2 and minus 2. So what we do is whenever we talk about the square root, we'll maybe getting two values, the positive value and negative value. Here we are talking about the deviation. We want to consider only positive value. That's why we have this formula as the positive square root of average of square of the deviations, square of the deviations taken from where? Taken from arithmetic mean. See, the positive square root, which means I'm talking about the square root. Am I right? Of what? Average. Average means what? You have to sum something and divide by the number of values given, n. Okay? Sum of what? Square of the deviations. Deviations means taken from where? Mean. This is a very important formula often asked. You need not make a note of it. I haven't finished the concept. You please have a look on this. I'll finish the concept and give you. Now we'll go for absolute measure is over. Now let me go for relative measure. Okay, yes, please join. Relative measure. You please refer the formula and join with me because it's quite simple only. Some small logic. That's it. Yes. What's the relative measure? It's called as coefficient of, because it's going to be a representative. That's why we use a coefficient of range. So first one is called as coefficient of range. Coefficient of range. Coefficient of range. L minus S is the value. Here we use L minus S divided by L plus S. Whenever we go for relative values, we usually represent in percentage. That's why multiply by 100. Okay. The denominator we are dividing by L plus S, right? Actually, in the numerator we have L, we have S, we are taking the difference. In the denominator we have L, we have S, we are adding here. The main difference is here we are using something called as interpolation and extrapolation formula. Okay, so you need not worry about the formula. It's extrapolation formula here. So if you want, you can make a note of here. Extrapolation formula. Which means in the numerator we take the difference, in the denominator we take the sum of the values. So this formula is L minus S divided by L plus S into 100. Next is coefficient of quartile deviation. Let me write it as QD. The same extrapolation formula is used. What is the formula here? Q3 minus Q1 divided by 2. So in the numerator, Q3 minus Q1 divided by 2. In the denominator, yes, please join. Q3 plus Q1 divided by 2. This 2 and this 2 can be cancelled. So directly I can write it as Q3 minus Q1 divided by Q3 plus Q1 into 100. This is coefficient of quartile deviation. This is also following this extrapolation formula. Okay. Only for first two. What about the next? For mean deviation, we'll not use this formula. Instead, we have a representative, solid representative here. Which value? For mean deviation, A. So here, it's called as coefficient of mean deviation, where I take the mean deviation directly. This is the formula for mean deviation, right? I take the mean deviation and I divide by A into 100. How you found your percentage marks in 10th, 12th and all? You add all the marks, divide by total marks. Divide by total marks is for which value you are comparing this one. So you're comparing this with A value. For this A, what is the deviation? So that's why you divide by A into 100. Okay. What is this A value can be? It can be mean, it can be median, or it can be, is it okay? Fourth one, standard deviation. The other name here, when you go for squaring the values, you call this as variance. Okay, so this is called as coefficient of variation. Okay, it's meant only for standard deviation only. So what's the symbol here? Sigma. So sigma divided by, yes please, what value? X bar. Why X bar? See, in the earlier case, coefficient of mean deviation, we were dividing by A because A can be X bar or median or mode. Here, it's only X bar. Because we are the definition itself says standard deviation is we are deviating from X bar. So this is divided by X bar into 100. So this is coefficient of variation. So these are the formulas. That's it. Main concept is over. Now I have to go for problems. Yes, can finish it off. Actually, design range, since you write this as design range, you have to write this as inter-design range. Inter-design range will be D7 minus D1, which means you're taking the first, sorry, D9. Sorry, I thought it's octave. பாருங்க என்ன கரெக்ட் பண்ற அளவுக்கு கொஞ்சம் ரெடி ஆயிட்டீங்க. D9 minus D1. Octile, which is O7 minus O1. This is also interoctile range. If they ask you as design range, you have to divide by 2. Okay. Why divide by 2? Why not by 9 or 10? Because you're considering two values, divide by 2. That's it. Because you use semi-inter-design range. Semi means 2 only, right? Percentile, interpercentile range will not consider P99. Instead, we consider P90 minus P10. Because the values, when you just plot the values roughly, you will get P1 over here and P100 over here, and P99 will be very closest to the value. That's why we are not going to consider this way. Instead, we'll consider P90 and P10. Okay, so we'll consider the difference between these two. And if you keenly check, you'll find that P90 minus P10 is the same as D9 minus D1. You agree with me? You can please make a note of this one also. Once was asked like this. D9 value and D1 value was given. You are asked to find the percentile value. So subtract, because your mind will be focusing on the percentile value, but the given data is with respect to desired values. Okay. So that's about the full concept. So now we can go for the problems 3, 6, 24 and 48. You can please start immediately. You not wait for me. What's the problem? The very first problem, individual observation from single material. So 3, 6, 48, 24. Already we have found the mean values. Can you help me out with the mean values? Mean, arithmetic mean. I think 20.25. Okay. Geometric mean 15, no? 12, no? Okay. Harmonic mean? Okay. Then median? 15, I think. Median is 15. Mode? Actually, it was well ill-defined. So we went for empirical relationship. 4 point? Okay. Now we use for, go for finding absolute measure and relative measure for dispersion. Yeah, please. First one, range. Finish it off. Range here, coefficient of range here. I'm not going to write the formula. I just want the direct values alone. It's there in the single material. If you want, you can refer it. But please try to do on your own. Second is quartile deviation. And here, coefficient of quartile deviation. Okay. Third is mean deviation and coefficient of mean deviation. Then standard deviation, coefficient of standard deviation, coefficient of variation, sigma, and variance. This is variance, this is variation. Okay, sigma. Yes, please. What's the value of range? What's the value of range? 48 minus 3, 45. Coefficient of range, L minus S divided by L plus S, 0.8823, or if you write it in percentage, 88.23%. Okay. Quartile deviation, which is Q3 minus Q1 divided by 2. Okay. 19.125. Coefficient of quartile deviation, 0.84 or 83 point? 0.8360. Wow. So 83.60%. Everybody are getting this answer? Usually we'll have it for two decimals. Okay. Mean deviation, where I'm taking A as X bar. Yeah. Value? 15.75. Coefficient? 778. 778. Okay. So this is 77.78%. Okay. Where X A is median? Same, no? Oh, very same, no? Okay, then quadratic deviation in this case, coefficient. This is for first A, second A, or no? Oh, okay. Okay, when A happens to be more, 1 8. Exactly. Okay, here in this case, oh no, no, something is wrong. See, if this happens to be 15.75 means, ah, that's okay. The mean deviation divided by A, right? Ah, so is okay. I'm just thinking why you're getting saying that. Okay, let me check. Okay, everybody got 400 and 105%. The same. What about others online? Finished till here? What about Sigma? Sigma is over. Are you doing it? 17 point. So variance. Coefficient of variation. Okay. Yes, please join. I'm working mean deviation about median. I just want to know the values. Please, everybody, join with me. What's the formula here? Summation modulus of x minus median divided by n. Okay. So we have the values 3, 6, 24, 48, and the median value here is 12. Median value is 15. Okay. So this is the x value, x minus median, minus 12, minus 9. So I'll take directly modulus value. So 12, 9, 9, 33. Okay. Yes, the sum of all the values. Okay. So here let me substitute 63 divided by 4, 15.75. Okay. We take it from mean. Mean is 20.25. So let me work it in red color. X minus x bar. What's the value? 3 minus 20.25 in positive value. 17.25. 14.25. Okay. We are getting the same 63. Okay. Okay, fine. Okay, no issues. Then mode. What is mode value? Let me work out this side. X minus mode value? 1.5. 1.5. So value? 1.5. And okay. So this mean deviation here will be 66 divided by 4. Value? Okay, here value 15.75. Here also 15.75. Okay, let me know the quartile coefficient of mean deviation also. Here 16.5 divided by 4.5. You said 400 percentage. Okay, so this is okay. Over here, coefficient 77 point. That's median. 105. It's 105%. And over here, 77 points. Please check whether everybody are getting this answer. Please check. Change of origin and scale. Change of origin and scale. To understand this property in a better way, actually we have to go for some graphical work. Okay. To understand this property in a better way, we're going to discuss a few cases. Originally, let me take a data with having the x values as 2, 3, and 4. Okay. Then I'm going to vary different cases, probably case 1, 2, 3, 4, 5, and 6 cases put together. First case, for each and every x value, if you add a number, for example, let me take the number as 2, which means instead of x, if you take x plus 2, what will happen? This 2 will become, this 3 will become, this 4 will become 6. Case 2, instead of adding, if I subtract, what will happen? 2 minus 2, see, from the original value only I am taking, okay. So 2 minus 2, 0, 3 minus 2, 1, and 2. Third case, from the value I multiply. Instead of taking x, I take 2 into x. What happens? 2 to 4, 3 to 6, 8. What happens? What happens means we are going to check all the measures. Okay, it's a comprehensive work, but no issues. We'll do it once. Next case. Instead of multiply, we divide x by 2. What happens? Actually, dividing is nothing but multiplying by half. You know this, right? Multiplying by half is same as dividing by 2. Okay? So what happens? 2 by 2, 1, 3 by 2, 1.5, or I can keep it as 3 by 2 itself. 4 by 2 is 2. Okay. Then fifth case. If I am going to multiply by a negative value, here multiplying by a positive value. Okay. Here I am going to multiply by a negative value. What happens? Same 2 I take it, but instead of plus 2 I take minus 2. So this is minus 2 into x. What will happen? 2 into minus 2, minus 4, okay, minus 6, minus 8. The last case, sixth case. See, so far, I don't know how far you noted. Let me have the writings over here. Here, you added a positive value. Here, you added a negative value, right? Added a positive value here, which is plus 2. Second case, you added a negative value. That's why it became minus 2, x minus 2. Here, you multiplied a positive value, so it's plus 2. Here, you multiplied a negative value, so it's minus 2. In the fourth case, you multiplied a fraction. Again, numerator by denominator form. Either it can be 1 by 2 or 3 by 2 or it can be anything. What is going to be the first sixth cases? You're going to add and also you're going to multiply. Both. So sixth cases, I'm going to consider this as, I'm going to multiply by 2. So 2 into x it will be. First I'm going to multiply by 2. So it's going to be 2 into x. Then I'm going to add 3. Okay, so what will be the values? 2 into x. So for each and every value of this, I have to take 2, 3 and 4, right? So let me work it over here. 2 becomes 3 plus 2 into 2. Yes, value 7. 3 becomes 3 plus 2 into 3. 6 plus 3, 9. 4 becomes 3 plus 2 into 4. 8 plus 3, 11. So here the values would be 7, 9 and 11. Okay. So now we are going to find all the measures starting from the beginning. Here, what is arithmetic mean? See, we're going to find arithmetic mean, median mode, not geometric mean and harmonic mean. So we'll find arithmetic mean. What's arithmetic mean? Pa? Yes, please join. Yes, arithmetic mean x bar. 3. Median. 3. Mode. For mode, we'll make a small alteration. Instead of 2, 3 and 4, we'll take 2, 3, 3 and 4 for convenience sake. So only for mode, you're going to work out 2, 3, 3 and 4. So mode value. Yes, please. 3. See, now it's easy, right? You need not go for empirical relationship. So let me take it in an easier way. So this will be the problem for mode. So here will be 3. Measures of averages over. Am I right? Then we go for measures of dispersion. Okay, in addition to that, I'm working quartile also. 1 second. What's the quartile? Can you help me with the quartile, please? Quartile 1. How will you find quartile 1? Size of quartile 1, size of n plus 1 by, sorry, 4. 4 observation. Yes, value? N plus 1 is 4, right? 4 by 4, first observation. Now, first observation is 2. So quartile 1 is 2. Is it okay with this concept? Quartile 1 is 2. Quartile 3. How you find quartile 3? Size of n plus 1 by 4, 3 times of this observation. So this is 4 by 4, 1. So third observation, 4. Okay. Then we'll go for finding mode. For mode, I'm taking 2, 3, 3 and 4. Okay. So here the mode value is 3. Okay. So this is done with measures of averages. Then we'll go for dispersion, range. Largest minus the smallest. 4 minus 2, 2. Is it okay? Range. Then mean deviation. I request you to find the mean deviation. The answer is 2 by 3. I directly take the value. Okay. Then I had to go for, we are not going quartile deviation. Okay. Quartile deviation will not get the result. I'll discuss that later. Then we'll go for standard deviation. The value will be 0.82. You need not work out. I'm just taking the value directly. Then this is sigma, right? Sigma square is 0.82 into 0.82. Value 0. So what is your task here is, please join here. What's your task here is, you have to find for all the 6 cases mean, median, quartile 1, quartile 3, m0 for measures of averages. For measures of dispersion, range, mean deviation, standard deviation square, no quartile deviation. For mode, you will consider this as the problem, not the original problem. Instead of taking 2, 3 and 4, we take it 2, 3, another 3 and 4. Okay, so you're going to do this for all the 6 cases now. Yes, x plus 2, where we are getting the values as 4, 5 and 6. Yeah, values bar. What is x bar? 5. Median? 5. Quartile 1? 4. Okay, quartile 3? 6. Yeah. Mode? Probably you might have taken as 4, 5, 5 and 6, right? Because 2, 3, 3 and 4 nala. 4, 5, 5 and 6. So it's 5. Then here, range 2. Mean deviation 2 by 3. Standard deviation, we're getting 0.82. Variance square 0.60. Any doubts still here? How did you work out? Directly apply the formula, right? Yes, online. Yes. For second case, x minus 2 value, x bar 1, median 1, quartile 1, quartile 3, mode. So what you did was 0, 1, 1 and 2, right? So you got it as, then range, mean deviation, standard deviation, sigma square. Third case, if over, give me the answers. X bar is 6, median, quartile 1, quartile 3. Okay, mode. So you got it as 4, 6, 6 and 8, right? So you got the value as 6. Yes, range, mean deviation, standard deviation, 6.3. 1.63. Round off to decimals, 2 decimals. 1.6329. Okay. Sigma square, 2.65. 65. Okay. Fourth case over means kindly give me the value. 1.5 or 3 by 2. Okay. Median, quartile 1, quartile 3, mode. So you might have got 1, 3 by 2, 3 by 2 and 2. Okay. So you got this as 3 by 2. Okay. Range, mean deviation 1 by standard deviation 4, 4 1, 408, so 4 1. Sigma square 167. Okay. Fifth case over means give me the answer. X bar is minus 6. Oh, I'm writing MD here. It's median. Median, yeah, median minus 6, quartile 1, quartile 3, mode. So you might have taken this as minus 4, minus 6, minus 6 and minus 8. Okay. Then range minus 4. Okay. Plus 4. How you found this range? Highest value is minus 8. Minus of Lowest value minus 4. Largest value is minus 4. Minus smallest value is minus 8. So this is minus 4 plus 8. So plus 4. Okay. So I'll place a star mark. R is, I'll write in full. Largest minus smallest value. Largest value is minus 4. Minus smallest value is minus 8. So this is plus 4. Okay. Yes, mean deviation. 4 by 3. Standard deviation. Sigma square. 6, 6. Okay. Yes, value. Okay. Don't give the values. Keep it as it is. Hope you have finished. It's very dark. Black nale dark thananga. நம்ம கட் எடுக்க வரலாம். Let me have black color. Okay. Because almost all the colors will look attractive over here. That's why. Okay. You might have drawn this graph, right? Can you help me out? Yes. What is this? Axis. Y axis. The meeting point is what you call as the origin. Usually we'll have this as 1, 2, 3, so on. And here also 1, 2, 3, and so on. Okay. Yes, help me out with the scale. X-axis 1 centimeter is equal to 1 unit. What do you mean by 1 centimeter? Means if you take the graph sheet, you will find that each one box, see this one box measurement. See this one box measurement will have 1 centimeter. Okay, that's why we take 1 centimeter is equal to 1 unit. Okay, then y-axis 1 unit. So in your 10th standard in the graph sheet, if you write the scale, you'll get 1 mark or 2 mark. Mark Akshira. Okay, pass. So this is a normal graph. Probably if I extend this line for negative axis, probably you'll have this side negative y-axis, this side negative x-axis, and this will be minus 1 here, and this will be minus 1 here. So this is the normal graph. What I'm going to do here is, I'm going to take another one graph. Okay. Yes, please join. I'm going to have x-axis, y-axis. I'm going to make some small alteration. This is 0. But what happens here is, I'm not having any values to be marked for 1 to 4 in x-axis. So what I'm doing here is, I'm going to take from 5. What would be the next value? I don't have the values from 1 to 4. So I don't want to take 1 to 4. I'm taking from 5 onwards. 6. Okay, correct question கேளுங்க ma'am. 8, 9. So likewise, what happened? Likewise, I don't want to have first 99 values of y-axis. After that only I require it. Probably it will start with 101, 102. Okay, probably you'll have this small line like over here. You remember? Okay, we'll just draw a shrinkage line. We call this a shrinkage line because we don't want the values till 4 and we don't want the values till 99 in y-axis. Actually, what I'm doing here is, if you write the scale here, can you help me out with the scale? Yeah, x-axis 1 centimeter is equal to 1 centimeter is equal to 1 unit. Confident? 1 centimeter is 1 unit only. See, here's 5, then 6, then 7. It's 1 unit only. Then y-axis 1 centimeter is equal to 1 unit only. There is no change in scale. Okay, there is no change in scale. But what happened is, I shifted the origin. Where? in x-axis, where should be this 5? Next to 4. But here I have written 0, which means I have shifted the origin from 0 to 4. Okay, likewise, what I have done here? Where should I have the origin? Next to 1. What I have done here? I have shifted the origin next to 100. This concept is what you call as shifting or change of origin. Scale is not changing. See, the same. Here, 1 centimeter is 1 unit for both x and y axis. Here also, 1 centimeter is 1 unit for both x and y axis. But what I have done, I have shifted the origin. Where? For the x axis to next to 5. That is 4. At that 4 place. For y axis, next to 100. Okay, this concept is what you call as change of origin. What is the symbol associated with this? Is if you go for mathematical operation, the symbol associated here is plus and minus. We are done with the 6 cases right before. In one case, I added plus 2. In one case, I added minus 2, which means x minus 2. In one case, I multiplied. In one case, I divided. So, if I add or subtract, it's nothing called as change of origin. Okay, let me go for another concept. Probably, I'll take red color. Same, x-axis, y-axis. Okay, x-axis and y-axis. What shall I have for scale? Origin, 0. Shall I take as 5, 10, 15, 20 and so on? Here shall I take as 100, 200, 300, 400 and so on? Yes, please. Scale. Yes, please join for the scale. X-axis, 1 centimeter is equal to 5 units. Why? See, it's jumping in terms of 5, factors of 5. So, 5, 5, 5. So, it's 5 units. Okay. Then y-axis, 100 units. Here, if you make a note, where is the origin? Next to 1 only. Am I right? Let me zoom out. Here is 1, here is 2, here is 3, here is 4. Am I right? And you can find 1, 2, 3, 4, up to 99. Yes, it's over there. What I have done is I have taken 1 centimeter as 5 units and 1 centimeter as 100 units. All the 1 value, 2 value in x-axis, all the 1 value, 2 value in y-axis, all there. What happened in the earlier case? What it was not there. I shifted the origin. In this case, which I'm marking in this red color graph, I am not shifting the origin, but what I have done here, I have changed or shifted the scale. This concept is what you call as change or shifting of origin. Is it okay? This concept is what you call as change or shifting of origin. Change or shifting, shifting of scale. Change or shifting of scale. If you go for the mathematical operation side, two signs will be associated with this. One is multiplication and another one is division. Okay. Now shall I? Case number 1. Tell me, what is the concept associated with this one? Yeah, please join. Yes, please join. This is one concept. X plus 2. Case 1. What I did? For each and every value of x, I added 2. This is change of origin with respect to positive value. Second, x minus 2. What I did? I shifted the origin. Actually, x minus 2 will look like this. Actually, the origin will be over here, right? This is origin. Instead of shifting to this side 2, I'm shifting to this side minus 2. Okay. So here it will be change of origin. Now come back for case 3. I multiplied by 2, which means this is change of scale. Here I divided by 2, which is change of scale. Here I multiplied by a negative value. Yes, still it is change of scale. Hope you can understand. Now compare for this one, 6th one. Yeah. What is this? Change of scale or change of origin? Both. Which one first? முடிவாங்க. Let me draw here. How it will actually look. Yes, please join. I'm taking x-axis and y-axis. Okay. Here is the origin. Please make a note. 5, 6, 7, so on. This looks like this one, right? The white graph. But instead of taking 5, 6 and so on, what I'm going to do here is, please make a note. I'm going to start from 50, 55. Okay. Then is 60, 65 and so on. And over here, I'm going to start with 100, 101, 102 and so on. Okay. Okay. தப்பா எழுதிட்டீங்களா மேம்? கரெக்டா தான் எழுதியிருக்கேன். Now tell me the scale. X-axis. So actually I have to draw the shrinking line, right? Because before 50 it should be 45, but I have taken 0 origin, which means I have shifted the origin from 0 to 45. So I have shifted the origin. 1 centimeter is 5 units. So which means here the scale is changed. And also, not only scale, and also origin is changed. What happened to y-axis? 1 centimeter is 1 unit. What happened here then? I have shifted the origin alone. What about the scale? It's 1 unit only. So I have shifted the origin alone. Okay. I'll give you some time later to make a note of this one. What you have to make a note here is, right over here. If it happens like the sixth case, what we were discussing, y is equal to 3 plus 2x, I remember. Am I right? 3 plus 2x. X is there. To this x, what you will do? You multiply by 2. This happens to be 2x. Am I right? Then to this 2x, I add 3. Which means to this first content, what I have done? I have multiplied. What has happened first? Change of scale, because I have multiplied. Second step, what I have done? I have added to each and every 2x, I have added 3. So what has happened here? Change of origin. So which one is taking place first? Change of scale. So you have to give this as order. Change of scale, then change of origin. So you can please make a note over here. This is change of scale first and then origin. Okay. In case, should I turn over? In case, if this is the one, seventh one. Seventh is not the case I have given. I'm just discussing. Y is equal to 3x plus 2. Which has happened first? To the x, 3 is multiplied. And after that, this becomes 3x. And after that, 2. Here also change of scale, then origin only. Okay. See, instead of writing 3x plus 2, I can write as 2 plus 3x. No issues. This is case 7. Let me extend. Eighth one. Eighth one is somewhat important. Eighth case. Y is equal to 3 plus x into 2. What happens here? Please make a note. If you're sleeping, please awake. First x, I am adding 3, which means what? I am changing the origin first. So I get 3 plus x. To each and every 3 plus x, I am adding 2. So after this, I am adding 2. So what has happened here? Change of. So what has happened here? Change of scale. Is it okay? So what you're going to do here is, you can please make a note of. We are going to focus on these properties dealing with mean change of origin and scale. Please focus on this. This property says arithmetic mean is affected due to change of scale and or origin. Please join. Arithmetic mean is affected due to change of origin, which means what? Addition or subtraction means you're changing, which means shifting. Instead of change, we'll be using another word called as shifting of origin. And or, which means both. Change of scale affects, change of origin also affects. change of scale, which is multiplication or division. Case 1, you remember? We did x plus 2. Case 2, you remember? We did x minus 2. Both are change of origin. Okay. What this property says is, if the values are 2, 3, 4 and your x bar is 3, after adding plus 2, your values become 4, 5 and 6. What is x bar? 5. It's nothing but 3 plus 2. You immediately don't say it's also 4 plus 1 now. In case if I subtract, what are my values? 0, 1 and 2. What will be my x bar? How can I write this? Now try to link with this. Arithmetic mean is affected. When is affected? When you change the origin. Which means to each and every value of x, if you add a constant value throughout, the arithmetic mean is also added by a constant. This is what you call as affected. Please focus, very important. What are the values of x? 2 is one value, 3 is another value, 4 is another value, right? To each and every value of x, you add what? 2, 2 and 2 throughout. Which means what? Each and every value adding the same constant. What happens? This becomes 4, this becomes 5, this becomes 6. Now you find x bar. What's the x bar? 5. What's the x bar for the original data? 3. How you got this 5? Because 2 is added. For each and every observation, which means for each and every x value, if you add the same constant 2, then x bar is also added with the same constant 2. Okay? Now, see here. I'm going for mean or no. I'll box it. What's the original x bar? 3. First case, you change the origin. 3 plus 2. Right? Second case, again you change the origin but minus 2. You got 1. 3 minus 2. What's third case? You change the scale. You remember? We were writing this. Change of scale. Which means you multiply it by 2. Again, if you check the property, what it says is also affected by change of scale. So whenever you multiply the value, the x bar gets multiplied. Whenever you add the value, x bar gets added. So each and every change you make to the observation, x bar also gets changed. See what happens here? X bar. What's the value? Yes. What's the value? How you get it? 3 into 2. What is x bar? You remember I was saying that don't write it as 1.5, keep it as 3.3 by that. That's why I was saying this. So this is 3 is the original mean, divide by 2. What is this case? Minus 2, right? You are multiplying by minus 2. Actually, original mean was 3 and you are multiplying by minus 2. Now, can help you with this case? I know you are working for the long one. So, I don't want to go for the long one. What happens if I use this property? Yes, tell me. 3 plus 2x. What happens first? Change of origin. So, here you multiply. That is for x bar, you multiply by 2. Which means it becomes 2x bar. X bar takes a value 3. Original x bar 3 then. So, this is 3 into 2, 6. Then what you do? You add 3. Sorry, am I writing right? Change of scale then. Change of origin. So, you add 3. You got the value 9? Please check. You got the value 9 over here. Shall I write the value of x bar is equal to 9? Okay. This happens, this is not only for arithmetic mean, but also for median, but also for mode. Now go and refer the properties of median and mode. Page 2.10, I remember. 2.10. What is the property of median says? The second property, please join. The second property, first property, sorry. First property. If x and y are two variables to be related by y is equal to a plus bx, which means what? How you got this y value? You multiply x by b, then add a. For any two constants, then the median of y is given by y is equal to a plus b, median of x. How you got this x bar value here? Y was there, a plus bx is there. For x, now we can take directly x bar and multiply by b. We have proved now. Okay, take x bar and multiply by b. You'll get bx bar. Then with this you add a. You get a plus bx bar. And for this you find the new mean value for y. It becomes y bar. So y bar is nothing but a plus bx bar. So what you can do is directly you can substitute instead of x and y value, directly you can substitute x bar and y bar value. Okay, this is change of scale and origin, both together. Either first origin, then scale, or first scale, then origin, both are same one. So we can take this as a result. Likewise for median, it is a plus median for y is a plus, here please join, a plus b median of x. Is it okay? Okay. What happened? What it says here, median is affected due to change of origin and or scale. You add or subtract the value, median will get affected. You multiply or divide the value, that is change of scale, median will get affected. Now let me check what we have done earlier. We just check this concept alone. We have done the complete problem. I'll mark it in red. What is median value? Original value 3. You added 2. So this is 3 plus 2. You subtracted 2. 3 minus 2. See, you need not work out the full problem. What you can do? Directly you can substitute the value. What happens here? 3 into 2. Multiply the value. Okay, what happens here? 3 divided by 2. What happens? 3 plus 2x. What is the median value? I remember 3. Right? Median value. Original median value 3. Then directly substitute over here. 2 into 3 plus 3. Which is 3 plus 6, 9. You got the 9 value? This is 9. Median. Okay. This happens for quartile also. You check here. Quartile. 2. This I'll make the tick mark. 2. Here. 2 plus 2. Here. 2 minus 2. Here. Into 2. Here. Divide by 2. Here. Into minus 2. You're getting the value? This is what you call as change of scale and origin. Last case. What will you get? Yes, please. Quartile 1. What will you get? 3 plus 2x, right? 2 into quartile. What's the original quartile value? 1. Sorry, 2. 2 into 2, 4. 7. You got 7? Please check whether you're getting for other 3. Yes, please check. Let me go this way. We have secured 50 marks, 60 marks, and 70 marks in 3 papers. Okay. So you know the mean value, you know the median value, just keep it as it is. You need not disclose to me. What happens is, after seeing the answer sheets, I find that 5 marks is out of syllabus. So what we have to default do is give 5 marks, which means you are adding 5, you are adding 5, you are adding 5. What happens? This becomes 55, 65 and 75. Now tell me, in this case, what is X bar? Average marks. Average marks means you find the X bar. What is the average marks? 60. In this case, okay. But you need not do this whole thing. What you can do here, you can directly add 5. You can directly add 5. Again, you can ask me, ma'am, just only 3 values I have. Directly, let me do it as 55 plus 65 and 75 divided by 3, I get it 65. If it's just only 3 students, it's fine. I'm having thousands and thousands of students. Is that I'm going to add for each and every student and find it? Not necessary. This is what you call as change of origin concept. Because what I have done? See, for each and every value 5 is added means it's automatically understood for the original mean, we are adding 5. Probably here we'll not name this as X bar. Instead, what we'll do? We'll name this as Y bar. From where we got this Y? This is X. For this, I added 5. So what I got here? X plus 5. This time I'm adding this as Y. I have X. What I'm doing? I'm adding 5. I'm getting a new variable, right? X is original variable. To each and every X, I'm adding 5. I'm getting a new variable. I'm naming this as Y. If Y is a new variable, means what is a Y bar value? How you get Y bar? How you got this Y bar? To this X bar, I added 5, right? Which means X now becomes X bar and 5, which you get it Y bar. This is not only for arithmetic mean, it holds good for arithmetic mean, geometric mean, harmonic mean, everything. But we are taking directly arithmetic mean only. Even for median and mode, we take it. Okay, now come for this page. Change of origin concept here and change of scale concept here. Okay, change of origin get affects arithmetic mean, affects or not? Yeah. Yes, affects, which means changes the value. Yes, changes. I'll put a tick mark. Change of scale affects arithmetic mean. Yes, affects. Put a tick mark. Next is median and quartiles. Does it affect the median and other positional average? Yes, put a tick mark. Does the change of scale affects? Yes, put a tick mark. Here, other median, sorry, mode. It affects mode? Yes. It affects scale, change of scale affects mode? Yes. Okay. So wherever I have x bar, what I do? I take x bar plus the related values, which I get y bar. Wherever I have median of x, along with median of x, I take the other values, multiplication, division, etc. What I get? I get median for y and so on. So generally what we write here is, here we write it as y bar is equal to a plus bx bar. What we write here? Median of y is equal to a plus b into median of y. Okay. And here mode of y is equal to a plus b into mode of x. Is it okay? This is x. Right as it is. Shall I go for measures of dispersion? Is the same case for measures of dispersion? Let us check. Go for the property in page number 2.11. Property number 2. Yes. Please join. Please join. Affected due to change of scale but by absolute values but not of origin. Affected, we have to check whether origin, change of origin affects and change of scale affects. What it says, affected due to change of scale but not of origin, which means if you change the origin, which means what? If you add or subtract the values, you will not find a change in the range, in the mean deviation and quartile deviation. Shall we check? Yes, go back to case number 1 and 2. Are you all here? See, I'm boxing the values. Change of origin does not affect range. See, what's the original range? 2. I'm adding 2. What's happening? No change. I'm subtracting 2. No change. Mean deviation. What's the value? 2 by 3. I'm adding 2. No change. Mean deviation for subtracting 2. No change. Likewise, standard deviation. 0.82. 0.82. No change. Variance. 0.67. 0.67. No change. This is for which case? Change of origin. Let me write over here. So, does it get affected due to change of origin? No, 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 no. Now let me go for this column. Shall I take over? Check here. Affected, you have to be very careful. Affected due to change of scale. What's written in the brackets? By absolute values. Which means if you multiply or divide, yes, it's getting affected. But what happens? If you multiply by -2, it will be affected by positive value only. But by absolute values means what? Sign is not given importance. Okay. Shall I go for third case? Yes, what's the third case? Remember? This is first case, second case. Let me write it over here. This is, we added 2, right? Please join with me. This, I subtracted 2, right? What I'm doing here? I'm multiplying by 2. It's a positive value. So no issues. What is R? Original R is? Original R is 2. Here I'm multiplying by 2. So gets multiplied by 2. 2 into 2, 4. Original value was 2 by 3. You remember? 2 by 3. What happened here? 2 by 3 into 2. See, it's 4 by 3. When you multiply by 2, the range also multiplies by 2. Mean deviation, standard deviation, everything multiplies by 2. But variance, we have to square the value and multiply. Okay, for variance. We have to square the value and multiply. Okay. Here, what you're doing, please join. You divided by 2, I remember, correct? Am I right? Please join here. You divided by 2 here. Okay. So range, what happens? What is the original range? 2. What happens? 2 divided by 2, 1. Each and every value, if you divide by 2, the range also gets divided by 2. Here, what is the original value? 2 by 3. You divide by 2. 2 by 3 divided by 2. What happens? 2 gets cancelled. 1 by 3. Okay. Here, standard deviation. What's the original value? 0.82. You divide by 2. 0.41. That's why I asked you to write 0.41. Here, sigma square. Actually, had square and multiply. We cannot directly take it. Then this case. Yes, come for this case. What you did over here, please? What you did here? You multiplied by? Yes, please join. What's the fifth case? What you did here? What you did here? Fifth case, what you did here? Into minus 2. Now come for the property. What it says? Let me clean the board. Change of scale, but by absolute values. Change of scale, but by absolute values. Which means, if you multiply by minus 2, it is considered as plus 2 itself. If you multiply by plus 2, no issues. Directly can multiply by plus 2. If it is multiplying by minus 2 means, it will not consider the negative sign, it will consider only the positive sign. That is about the case 5. This is the case 5th case. What's the R value? Original R value? 2. What happened here? 2 into, actually should not take minus 2. 2 into plus 2 itself. What happens here? Mean deviation was, remember, 2 by 3 into plus 2 only. Here, standard deviation, 0.81, 0.82 into 2. Okay, actually this should be 4 then. Here, sigma square, you have to square and multiply. Are you okay with range, mean deviation and standard deviation? We are not discussing quartile deviation because quartile deviation is not giving the uniform results all over. That's why we are not discussing quartile deviation. Leave off quartile deviation. Okay. Now come over here. Please join. Range of y. Actually, this is the equation. Y is equal to a plus bx. What is happening here? Change of scale is happening. Am I right? Please join. What is happening here? Change of origin. What the property says. Range is not getting affected by origin but by scale. So range of y will be, this will become 0. Why? Change of origin is not affecting. Which means it's not having an impact. It's not having an impact is 0. Okay, it's not having an impact means take the value 0 because it's not affecting. But what happens here? R becomes range of x and b is multiplied by of x. Likewise, you go for mean deviation. 0 plus b into modulus of, why you take modulus of b means because of absolute value. Standard deviation, you take 0 plus modulus of b into standard deviation of x. Now come for variance. You might be wondering why I am using sigma here and in the material is S. You should not use sigma actually, but colloquially interchange. Sigma is meant for population and S is meant for sample. Okay, you know this concept? N and capital N. N we use it for sample, capital N we use it for population. X bar we use it for arithmetic mean of sample, mu we use it for population arithmetic mean. Okay, likewise sigma S has to be used for this one and sigma has to be used for population. But usually interchange, no issues. That's not a wrong thing at all. There's another one logic behind that, no issues. So whether you're using sigma or S, it means the same only. Illogically is not right, but depending on some circumstances, I can use it. Okay, so let me come back here. So what is here? Variance square. Sorry, sigma square, right? So S square or variance, it's not having an impact on origin. So 0 plus, when you go for change of scale, actually for these three cases you took absolute value, but for this one I'll place a star mark. You have to square the value and take the variance of x. What was the problem? Variance of y, which means 0 plus 2 square into variance of x. What is variance of x? You got? Please give me the value. What is variance of x? 0.67, right? 0.67. Okay. Y is equal to 3 plus 2x. Yes, please. This becomes 0 because no impact. This becomes, because you're taking variance, it should be squared. Okay, so this becomes 2 squared into 0.67 value. Two point. You're getting the same value which you did earlier for this one, last one. For sixth case, more or less the same value. Exact more or less the same value. Because decimals வந்து நம்ம 10 places வரைக்கும் பார்க்கணும். 10 or 15 places பார்க்கணும். அவ்வளோலாம் நம்ம பார்க்கவே இல்லையே. உங்க calculator 7 or 8 places வந்துரும்ல. You're not checking all this. So if you check this value, instead of working the full problem, what we can do here? Okay, tell me. We worked out the 6 case, right? Why it took so long, lengthy time? I'm asking everybody. 6 cases, why did you work out so lengthy? It took a long time, right? Why did it take a long time? Where you found the difficulty? Yes. Where you found the difficulty? Finding mean deviation. Because mean deviation formula is summation x minus x bar by n. So whenever I change the first case to what? 4, 5 and 6, I found this one. Complete working was there. And standard deviation. What happened? This is a formula. Ma'am, you asked to do it, ma'am, for all the 6 cases. For each and every one, I was putting the table. Who was the one putting the table? Backstage. For each and every problem, we had to put the table. What table? 4, 5, 6. Then this is x. One column for x minus x bar the whole square. Then you added everything. Who's this one bar? Yes, I saw your paper. This is the right work. Now nothing is wrong in that. Then you added all the values, then you divided, then you took summation. That is a square. You did not do all these things. What's a simple problem? Now here y is equal to x plus 2. Ma'am, we want standard deviation, ma'am. The standard deviation of y is equal to standard deviation of x plus I. Read the property and compare. Read the property. Change of origin does not affect. So what you have to do? What value will put here? 0. See, this 2 is independently standing. So what happens here? This is becoming 0. What happens here? Sigma x. If this is y is equal to 3 plus 2x, you're going to find sigma y. Yes, please join. This is 0. This one. So 3 becomes 0 because no impact. 3 becomes 0. 2 becomes 2. Change of scale will be taken. Positive value will be taken. So it's actually going to be modulus 2. Okay. This is sigma x. I was taking this 5th, 7th, 8th case and all, right? Remember? Yeah, this one. Yes, can you help me out? See, you can very easily find without any extra efforts. Yes, tell me. Here y is equal to 3x plus 2. Yeah, tell me. What is range of y? X. What is range of x? I think 2, right? 3 into 2 plus 0. That's it. What is sigma y? 3 into, I think sigma value was 0.81 plus 0. That's it. Over. For this one, the 8th case, y is equal to 3 plus x into 2. Yeah, tell me. Please don't do directly. Instead, what you can do? We can multiply 6 plus 2x. You're not okay directly with the concept because here if you put 0, it will not having a matching. So directly you can take this as 6 plus 2x. Okay. So this is change of scale and origin part. So ultimately, we are having this concept related to this one. For variance, we have to square it. 0 for change of origin. For change of scale, you have to square it. For range, mean deviation and standard deviation, 0 for change of origin. but you have to take modulus value for change of scale. Okay. We'll be using the same concept not only for averages and dispersion, we'll be using the same concept for dispersion, correlation and regression also. The same concept will be using. Okay. This is often repeated question. That's why I just went in a relaxed manner. So remaining properties I'll discuss in the next class. Okay. So I have measures of dispersion property 1 and remaining properties in here. Property 3, 4 and this discussion. So probably it will take another half an hour for me. I don't want to drag